So one of the things that's escaping from the wireless space and getting a lot of attention pretty much everywhere is the Internet of Things. Frankly, we were talking about that today, and quickly became apparent, on thinking about it. I don't know about you guys, but I actually have 3 times as many non-computer devices on the network than I do computer devices. And yeah, I'm a bit of an early adopter, but I don't think I'm a crazy early adopter. And I think more and more of us are starting to have, devices that are not computers, devices that do things, single-purpose devices. One of the things I pointed out this morning, when doing a little research on the Internet of Things, I found that when it was coined, it was intended not to be connected to the Internet of People. It was intended to be its own, not even internet really, but the intranet of things, sort of, that the devices would all talk only to each other. That's not how it is. All these devices are going on the internet. All these devices are going to have IP addresses and are going to be, connected. We just got a little bit into that when we were talking about tags and location-based services. There's a whole world of problems here, and there's a whole world of concerns, and there's also a whole world of cool stuff that you can do with this Internet of Things. So, who wants to start our discussion of that? You want to jump in there, man?
I think Asma probably has.
Yeah, I was going to say Ryan probably loves to talk about the iKettle and things.
Oh, all right. Tell us about the Internet of Things.
So, with the Internet of Things, like you said, they're connecting directly to the internet, but there's still a lot out there that's not. Like Hue runs Zigbee. Wemo, the switches and all of their devices, they connect to Wi-Fi. What else is there? There's devices that are home automation devices that are running Bluetooth.
Are they the Internet of fragmented things?
Oh, it's just a mess. And you have all the systems running proprietary protocols or open protocols, but they do it a bit differently, which kind of sounds familiar in the Wi-Fi world.
And it's the cheapest card.
It's the cheapest card. Everything is 2.4 only. I've had some serious issues with some of the devices that I use requiring 1 megabit per second beacons.
Yeah, they're 2.4 only, and they're hard coded to like channel 10 or something like that. and there's no way you can change any of the settings of the actual Wi-Fi that it's doing. It's going to be doing max power. It can, and then you're kind of just stuck with this. This RF bomb just kind of living in your environment now.
Yep.
Whether it's your laundry or your refrigerator or whatever you've invited into your home, right? And there's nothing you can do about it unless you just unplug your devices and don't use them.
But how much of it really truly matters in your home?
The home is one
Your home,
thing.
it doesn't matter. It's when these things like the Apple TV and everything that have gone from the house to the corporate environment.
It's an aggregate, because each one individually has very, very low data rates. And so, yeah, it's in a bad place. There might be 1 megabit data rates at full power off of that $1.25 Wi-Fi SoC. And that's why they're not working very well.
But it is an aggregate, like you said, because when you get to enterprise use case with like facilities automation, these are going to be pervasive.
Yeah.
For lighting, for doorways, for security locks, for all sorts of things. And there's not going to just be like 2 or 3 of them around. There's going to be like one everywhere, like 3 feet around the building.
And I got to tell you, I agree that I wish they were using 5 gigahertz chips, because in reality, the cost is not that much different. But these little embedded systems with the built-in chips where you're hard coding them, I started messing with those things, and I am so glad they run 2.4, because they are such low power that they wouldn't be able to hear my router.
And I don't know that we have a real concern about them using a lot of the 5 gigahertz band that have spectrum sharing regulations, because these small embedded devices, they're not going to be able to afford to put the logic in there.
For DFS.
For DFS, for instance, for radar detection. And the new spectrum that we're looking at getting is going to have all of those spectrum sharing regulations similar to DFS, because that's the only way we're opening up new frequency.
Yeah, when you're talking about a sub 100 megahertz processor powering that Wi-Fi chip, you go.
But I'm okay with that because then that means they're not using it. It's not gonna impact a large
Well,
portion.
that was my point, that's what I
Have you seen
think
that
too.
graphic
I don't
that
have.
shows 5 gig, 2.4, 900 in a house?
Yeah.
And we're like, yeah, so I don't care if they're using 900 and it can go to my neighbor's house, but I do care if they're on 5 gig, so.
Yeah, that's what, I would rather have them on 2.4, put all my other stuff on 5 gigahertz. But the other concern that I have, well, and also because it makes it, I don't have to worry because like you said, it's low data rates. I don't care, I'm not on 5 gigahertz, let them do that. But the other concern that I have is the security on a lot of these things is so poor.
Lack of security.
Lack of security.
Well, and
is
there's
so
not gonna be
poor.
software upgrade cycles like we're used to on end user computing devices. These things have to ship out of the box in a secure fashion, and if they're not secure, they're never getting secure.
And they're not secure.
Well, and
Right.
They're shipping it today and they're not. So
And
we're
that's-
just-
And they're targeted for a consumer base, that's why. But we, again, like these
But
devices.
industrial,
we
they're
find
gonna,
that-
they use the
show
same
up in the
thing showing up
enterprise, that's the
in
problem.
enterprise.
But the other thing, regarding the security issue is that for home users, I think it's more of an issue for home users than enterprise, because enterprise, a lot of times we have the tools to separate them or give them different roles, In our case, we can identify them and put them in different roles, lock them down, do things like that. But a home user, they don't. They just have maybe a guest network if they're lucky, if they have a router that's a home router that supports that. And then they really don't have, other than that, they really have no other way
I don't
to secure
see
it.
facilities, as facilities start taking over, and the facilities will have them, their facilities isn't IT.
Right.
And they're gonna.
one of the biggest problems I see with that is we're talking about Wi-Fi. Who here's played with an Arduino or a Raspberry Pi or anything like that? You have the ability to sniff and crack Zigbee.
Yeah.
Zigbee has no security. So for all this automation stuff, that's a big problem.
And we're not just talking, I just want to point out here too, there's a lot of scary stuff that you can do with these things. I mean, we remember the video camera hacks and so on. I mean, and they're talking about sensors, they're talking about lights, they're talking about heating and cooling. There's a lot of stuff you can do here. We've got a question here in the audience too. You want to jump in?
Obviously, the more things you connect, the more insecure it is, right? So when you're talking, what's it take for somebody to hack into those and get access to your home, lighting, whatever, right? I think that's right? So I think that's the bigger discussion that needs to take place, in that the industry needs to answer those things. So we're not just talking about the technology, the connection, but security, I think, is really the discussion that needs to take place.
Well, nobody thinks when they start building this technology. Years ago, did anyone imagine that you could buy a software-defined radio for $10 that can break into all of these different protocols that aren't secured because no one's going to mess around there? And you mentioned cars. No one's going to break into a Wi-Fi access point in a car, right? So let's connect it to the ECU. Why not?
Airplanes.
Airplanes.
Cars now do come with Wi-Fi.
Exactly.
That was the point.
And they're connected to the ECU.
Yeah.
So if you can get into one, what's stopping you from getting to the next layer?
And also, what's stopping you from using the Internet of Things backwards and using it as a way to get into a secure space and into a secure network?
Right, and I think part of what he was getting to is not only the access layer security of the RF, the wireless layer, but the data and the data layer, because we got a lot of big data coming down the pipe with IoT, right? That's got to get stored in the cloud, most likely somewhere. And how is that being stored to make sure that data doesn't, get stolen? I mean, you see data breaches every day now, and it's just ridiculous. So there's two components to that.
We've got another question here in the audience.
How's it going? You mentioned facilities. There's facilities going to take over. I work at an educational institute. I'm the guy who does the wireless. When I get back next week, I've got two things I've got to go do. The first thing I've got to go do is meet with Residence Life, because they're bringing in a truckload of washers and dryers that they're expecting to drop on the Wi-Fi. So you can get updates, your dryer's done or your washer's done. Okay, they had the decency to call me ahead of time, and I'm going to get the demo it, and I'll be able to give them a thumbs up, thumbs down, this will play nice in our environment, or move.
So it's a thumbs down, right? You've
I
already
want
decided?
those. I would have loved
I'll meet with the guys. I'll meet with the guys. I'll give them a chance. But the second thing I've got to go do is go yell at the head of facilities because before I left, a crate of electric meter monitoring things showed up, got installed, and now need to be connected to wireless. Nobody told me. I got a call like Wednesday before I left. Hey, can you come down and check this thing with wireless because we bought 30 of them and they're going all over campus and they're tied into the power grid.
What could possibly go wrong?
Yeah.
And you're right, 2.4, they're the cheapest chip, and I have no idea what they're gonna do to our health. I don't know if I can even make it work, but they're already done and they're installed, so if it gets sat down in front of the cabinet member, somehow it will be my fault that I can't make it work, even though nobody talked to me before.
It never happens, does it, George?
And who guesses if it's even secure on top of that?
Yeah, so my struggles are your struggles. You know, I'm in healthcare, and I had to build a lot of bridges to facilities and to desktop and to security, get everybody involved and sometimes get folks in the same room, and say, I know you purchased this product, we haven't tested it, it's not working. Let me educate you why it's not working. We have a similar product that, we put our own bridge on, for example. We can make it work. But you have to get in front of that curve. And we always get those curveballs. In fact, my friend, I'm going back to a similar, got an email yesterday, hey, we got these, we need to get them on a network. Put the brakes on it, here's our policy.
Yeah, wireless engineers are, if 50% of your job isn't communications and relationship management with peers across the business organization, quite frankly, you're living in a hole that you need to get your head up out of. Because
Yeah, we just talked about that a few minutes ago.
Yeah, you have to be involved with every area of your business and establish those relationships. So we've got it from two sides, right? You spoke a little bit earlier about getting out there with the end users. You got to do it on the other side with the business organizations and the peers across the organization as well.
Yeah, and even the vendors, like in healthcare, we build bridges to GE and Philips, right? It's a horrible situation. They bring in this $80,000 EKG. The wireless option has a lot of zeros on the back of it. And you go to look when they have problems, it's a $35 wireless NIC. But it's my problem. And by the way, I'm the only hospital that has this issue. Come on.
We have time for one more comment here. Yep.
So, as a geek, the Internet of Things, at first glance seems exciting. It feels promising that there are things that you can now touch and do, which were never possible in terms of, someone comes to my door, I can now see who's at the door and talk to the doorman. I can unlock the door automatically as soon as I approach it. But as soon as you step back and take a rational approach to what exactly is happening, you're exactly right. How do these things get patched up if there are security vulnerabilities? And this actually is, I think, the biggest threat in terms of these are just going to be bots sitting out there for somebody to take over and launch attacks, which at that point you have very little control over, right? So from that perspective, I think a standardization of some way enforced overall on whatever gets released as an IoT device is the key to long-term success. Otherwise, these are just going to be.
So are you
the Internet of bots.
Are you referring to a standard from a standards body like the Wi-Fi Alliance, or a standard within your organization, or a standard within multiple vendors?
I think standard between multiple vendors, so that.
So maybe the chip manufacturers could actually have a standard?
I don't know if, because this will be a national threat at some point too, right? So, at what level does this conversation need to happen so that it really gets enforced and taken really seriously before it gets out?
Well, and I think that's exactly right. We have to have vendors cooperating for a standard because you can't write your own security protocols and hope that they're going to be good, right? It's the classic, that's one thing you don't try to do on your own. It takes a lot of time and a lot of collaboration between a lot of really experts in the field to really hack and stress and make sure and verify the security of proposed security standards. So
They would actually have to go down to the chip level because some of these CPUs that they've got in their little SoCs can't handle any of the current standard security processes.
Yep.
But to be honest, to go back to your point, it doesn't matter. The manufacturer is working their hardest to get first to market. and they want to be first to market, they don't care about security. Who cares,
And
right?
cheap.
Yeah.
And
It
there's no
doesn't-
requirement
it
for them,
honestly, it
even with the
doesn't
Wi-Fi
matter.
Alliance, they just say, okay, well, I don't want your sticker on
Yeah.
my box, and I'll just put it
And-
out anyway.
But it's a serious
Even-
point, though. I mean, if all this information's going to the cloud, somebody gets a hold of that cloud, now all of a sudden they literally have world domination, create their own bots, right? It's actually a valid point.
And I think what you'll find is there's going to be some point where you can mitigate it to a certain extent because it's proximity based, and you're going to see a whole bunch of hacks and works around, well, it only works within 30 meters, so let's do some sort of physical security.
Well,